On this slide, we're going to talk about the structure of a complex number. Complex numbers are generally written in the form of a plus bi, where a is known as the real part and b is known as the imaginary part. Take note of the fact that the imaginary part b is just the number in front of the I. You wouldn't want to include I when someone asks you what is the imaginary part. Two complex numbers are equal if and only if their real and imaginary parts are equal. This is a very common question asked in a section in any Algebra 2 book on complex numbers. 2a. Find the values of x and y that make the following true. 2x plus yi equals negative 14 minus 3i. Well, if I look at the left-hand side, we've got a real part and an imaginary part of a number in complex form. The real part on the left-hand side is 2x, and if we jump to the right-hand side, we have another number written in complex form, and its real part is negative 14. So there's a correspondence between the real parts on each side. This is going to enable me to write an equation, a very basic equation. 2x equals negative 14. Dividing both sides by 2, we end up getting x equals negative 7. So we're halfway done with this problem. Now I'm going to look at the imaginary parts of each side. The imaginary part on the left side is just y, it's just the element that precedes the I, and the imaginary part on the right-hand side is negative 3. So this equation is going to be y equals negative 3, or y corresponds with negative 3. So these are the two values of x and y for which this equation would be true. Let's try another one. It's a little bit more complicated. 2b says find the values of x and y that make the following true. X plus 6i equals 3 minus I plus 4 minus 2yi. So what I think I'm going to do is focus on the right-hand side where there is something more that I have to do. And I'm going to start by clearing parentheses. Staying on the right-hand side, I'm going to collect like terms. All terms that are real that don't have an I associated with it, and then collect all terms that do have an I associated with it. So the 7 happened because I combined 3 and 4 together. Then I've got two expressions with I, negative I and negative 2yi. And what I'm going to do is focus on those very last two terms, and I'm going to factor out the I because it's common to both. So that's my next step. If I take that I out, what do you think is going to be left over? If you said negative 1 minus 2y, then you're correct. And you could always check yourself by redistributing the I back into that parenthesis to see if that's what you started with. Now I'm going to set up my correspondence. The real part on the left-hand side is x. The real part on the right-hand side is 7. So x equals 7. That was easy enough. Now I'm going to look to the imaginary part. The imaginary part on the left side is 6, and the imaginary part on the right side is negative 1 minus 2y. So I'm going to set those elements equal to each other. Adding 1 to both sides, I get negative 2y is equal to 7. And dividing by negative 2, I end up with y equals negative 7 halves. So here are the values of x and y, which will make this equation true. In summary, if a number is supposed to be expressed in complex form, it needs to fall into the template of a plus bi. The a is the real part, and the b is the imaginary part. In this slide, we're going to do a few more basic operations with imaginary or complex numbers. On the very top left, though, I'm just going to write a fact that we reviewed on a previous slide, but I just want to have it at our fingertips should we need it again. And that is I is defined to be the square root of negative 1. Okay, so let's take a look at example 3. Example 3 has us multiplying negative 3i times 2i. Well, what I'm going to do is I'm going to group all the numbers together, and I'm going to group all the i's together. Negative 3 times 2 is negative 6. I times I is I squared. So we end up with a product of negative 6i squared. I squared, though, is negative 1. So this becomes negative 6 times negative 1, or just 6. In example 4, we need to treat each radical like grouping symbols and complete each of the separate problems first before we do the multiplication. So the square root of negative 12 can be thought of as the square root of 4 times negative 1 times 3. And when we simplify this, we end up getting 2i square root 3. Now if we look at the second radical, it says the square root of negative 2. And I'm going to think about this as the square root of negative 1 times 2. And this, of course, turns into I root 2. So I'm going to take these two results that we got independently, and now I'm going to multiply them together. And I'm going to do that up top where there's a little bit more room. So if I look at all my numbers, it looks like I've got 2i squared root 6. A moment ago, we reviewed that I squared is negative 1. So our final answer is going to be negative 2 root 6. In our fifth example, we're asked to add two complex numbers, 7 minus 3i plus 4 plus 5i. So basically what I want to do first is just clear the parentheses. And now I want to collect like terms. The 7 and the 4 give us a total of 11, and the negative 3i and the 5i give us a total of 2i. So our final answer is 11 plus 2i. In question number 6, we're subtracting one complex number from another. 2 minus I minus 8 plus 3i. Let's start by clearing the parentheses. Don't forget, when we subtract, we have to distribute the negative, and I'm going to have minus 8 and minus 3i. Collecting like terms, we end up with negative 6 minus 4i. And finally, in number 7, we're asked to multiply two complex numbers together. 2 plus 3i and 5 minus I. As you may have guessed, we're going to FOIL. First, outer, inner, last. The product of our first is 2 times 5 or 10. The product of our outer is 2 times negative I or negative 2i. The product of our inner is 5 times 3i or 15i. And the product of our last is 3i times negative I or negative 3i squared. Being mindful of the fact that I squared is negative 1, we really have a plus 3 at the end. And the 10 in the beginning and the plus 3 at the end are going to give us a total of 13. And when we combine the I terms, it's going to be plus 13i. So on this slide, we talked about adding complex numbers, subtracting them, multiplying them. And then we had a question like number 4, where we had to treat each of these radicals as independent radicals and then multiply the results together.